Thank you. Hi everyone. I'm Sebastian. The problem that we study the problem that we study in this paper has two main motivations, and it's a problem of diagnosing arthritis. The first motivation is that arthritis is extremely widespread in our society, and it causes some severe physical disability. Um, this presents a need for cheap and fast diagnostic tools for this disease. The second motivation is that the currently used clinical features to diagnose the disease are fairly simplistic and do not capture the full characteristics of arthritis. So our main goal in this paper was to develop some new diagnostic tools that are more sophisticated but still fast and cheap to use. This shows the data that we have. Essentially, what we have for each patient are three functions. They're the result of three different tests where the hand force function for the patient was recorded. This was done using a standard hand grip device, so these tests were fairly cheap and fairly quick. And essentially, we concatenated these functions into one data object for each person. The top row shows a case of severe arthritis. So this essentially this diagnosis is very easy. The difficulty in the application is shown in the bottom panel, where in panels D and E we show a healthy patient and a patient with mild arthritis. And so essentially what we need are better features, not like the classical features that cannot distinguish between these two patterns. And so all the data is shown in panel F. To attack this problem, we use an elastic functional data analysis framework. The basic premise behind this framework is that the functions we observe have two sources of variability. The first source is the amplitude, which essentially is the magnitude in the force, and the second source is the warping or phase, which is the timing of features as they appear in the function. And so you can essentially see the idea from the top illustration. The functions we observe clearly differ in phase or x variability and amplitude, which is the height of the functions. And the idea is to separate these two sources of variability before doing any sort of statistical analysis or developing the features. And so you see the phase variation is at the top, which is captured using what are called warping functions, which have a special structure, and then the amplitude variability are essentially the aligned functional data. So you can see an application of this idea to the data that we have. The top row shows the controls, the bottom row shows the patients. Panel A has the original functions, B has the aligned functions. The phase variability is given in panel C. Then we have the function, the amplitude plus and minus 1 standard deviation in panel D. And so this framework is very flexible in that you can do many things with it. And what we ended up doing was developing new automated features based on functional principal component analysis. And so these are the 5 features that we used in our classifier, and they're essentially related to the principal directions of variability in both amplitude and phase in the functional data that we have. And so at the top you see a picture of this variability where we essentially look at the directions of principal variation from -1 standard deviation to +1 standard deviation. And if you look carefully, I'm not going to explain this in detail, you can come to the poster, but if you look carefully at these principal directions of variability, you'll notice that they represent natural variation in the disease, so low force to high force, essentially. So what have we accomplished? We essentially can show improved separation of the two groups. And we've developed a sophisticated and yet effective and quick and easy diagnostic tool for determining hand impairment and function. The improvement in classification is also given, and we've run multiple tests, and many more results are shown in the paper. In the future, we would like to study this disease actually in much more detail, so develop functional regression models where we can include covariates and do many more things. This paper was mainly about the diagnosis or classification. Okay, thank you for your attention.